Hello, my friends. So today I'll be going over how to do section 6.2 in Myopenmath, specifically problems 9 and 10. So this is problem 9 right here. And I took the liberty of copying and pasting the graph into a Google document so that I can highlight it and kind of show you where my thinking was. And so this is the answer I got. As you can see, it's correct. But we are going to just look at the graph and work from there. So it says, write an equation for the function graphed above. And so the first thing I'm going to find is the midline. As we know, the midline is represented as C within an equation. And it is basically what cuts the function in half horizontally. So basically, it's a horizontal line that cuts the function in half. And so, as we can see here, we need to find that midline. Of course, we know the midline is going to be invisible, but normally how I figure out the midline is that I try different numbers, that these humps are in between. Sorry to call them humps. I'm not really sure what else to really call them. But as we can see, the numbers 4, 3, 2, and 1 are between them. So we can just test this out, make sure each one is the even distance from whatever our midline is. So let's try 1, 1, 2. Nope, 1 does not work. Okay, let's try 3. 1, 2. That's 2 up from 3. But that I can already tell that's a little too low from 3. And we're not even going to try 4. So let's try 2. 1, 2, 3. 3 spaces away from 2. 1, 2, 3. 3 spaces up from 2. So it seems like 2 is our midline. I'll even do it in blue so that you can see that this is where our midline is going to be. And from there, we already know how to get the altitude from the midline. 1, 2, 3. And then from this midline, of course, 1, 2, 3. So our altitude is going to be our altitudes are going to be 3. So we already got that our midline is 2. Our altitude is 3. And our period is simply going to be how many spaces one max is to another max or one min is to another min. So let me draw that in a different color. Let's try this from here, from point -6, -1 to point -2, -1. And let's just see how many spaces that is over. So that's 1, 2, 3, 4. So that's 4 spaces. And let me write the 4. So we're going to use this number for our period. And we already know the formula for period is 2 pi divided by b. You can either do the cross, you could do the cross multiplication, or if you already know and you're feeling comfortable with knowing a period, you can simply put 4 on the bottom because that's the amount of spaces, and also the end result of the butterfly method, you'll get this. And so our period will be 1/2, oops, 1/2 pi. So if you put all these pieces together, your equation, well, at first this is the formula that we need. And we're using secant because, as you can see, this looks like a secant graph. It seems like you did pretty good on number 2 when it came to like identifying what type of graphs the graphs are. Well, as you can see, this is a secant graph because some of the little humps are on the top, some of the little humps on the bottom, and it just looks like a secant graph. So we are going to use secant, and the rest of it is going to basically be the same as we did in previous problems, and then plus your midline. And so now that we have all our parts, our formula for this one will be 3 secant 1/2 pi x, because there is no horizontal shift, plus 2. And that is what we have here. Of course, you'll put like the y equals, but yeah, that's what we have here. Okay, give me 1 second and we will move on to doing number 10. So I am now back, and now we're going to do number 10. And so just by looking at the graph, we can tell that this is a CSC type graph, as we can see here. I need to remember what CSC means, so give me 1 second. Cosecant, yeah. Okay, so this is a cosecant graph, or just CSC. So we already know that is going to be the same process. So first we're going to have to find our midline. So let me draw it here. I'll do it in this color. So let's see. 1, 2, 3. 1, 1, 2. 1, 2. 1, 2. 1, 2, 3. 1, 2. 1, 2, 3. 2. 1, 2, 3. 1, 2, 3. Okay, so after taking a bit of time for me, I finally figured out that the midline is going to be at -1 because it's the same amount of distance from these humps and this hump. And we can tell this is a cosecant graph because like these humps are a lot more and a lot skinnier compared to the one from number 9, which is a secant graph. So now we're going to figure out the amplitude. Again, amplitude is simply how many spaces the maximum is from the midline, or the minimum is from the midlines. So let's do that now. Let's see. 1, 2, 1, 1, 2. So this is 2. And 1, 2. And then this is also 2. So our amplitude is going to be 2. And of course, our period is how many spaces one minimum is to the next minimum, or one maximum is to the next maximum. So let's see, how many spaces is this? 1 space, 2 space. So this will be 2. And so we're going to do our math down here. Here you go. We got our midline, which is -1. We got our amplitude, which is 2. And then we got our period, but we got to do the formula, which of course 2 pi over b. But since we're so pros at this now, we can just do 2 pi over 2. So we know it's 2 spaces from one max to the other max, and it's evenly distributed, so we already know. So that would just leave us with either 1 pi, or you can just write pi. And so our final formula should look something like 2CSC pi, and of course that's x minus 1, y equals 2CSC, parentheses, pi times x, parentheses, minus 1, and that is what we have up here. And of course, you can always check your answers on Desmos. Of course, you already know how to get to Desmos, you know. Desmos, graphing calculator. We can go to here. It's loading, okay. And then we can just simply type the equation in. And we can compare points like -2, -1, -2, -1, etc. and see that we have the equation that we need. So yeah, that is how you do numbers 9 and numbers 10. And I hope this helps you, you know, because yeah, I know this is very complicated, but if you ever have questions, you know, reach out to me. I'm always available. Okay, see you later.